Assalamualaikum and good afternoon to all for the students. Sorry because I sent this video a bit late. Okay, so we will continue our lesson in chapter 5, chemical bond, and our subtopic for today is 5.3, covalent bond. Okay, as you can see in the picture, there's diamond. Okay, and a diamond is the hardest substance in the world. Okay, the property of diamond is caused by the formation of covalent bond between carbon atoms. Okay, so what is covalent bond? Okay, covalent bonds are formed when non-metal atoms share their electrons to achieve a stable duplet or octet electron arrangement. Okay, so it is between non-metal atoms. Okay, so there are three types of covalent bond. The first one is single covalent bond. Okay, it is formed when two atoms share a pair of electrons. Okay, a pair means single. Okay, number two, double covalent bond. Okay, it is formed when two atoms share two pairs of electrons. Okay, so one pair is single, so two pairs is double. Okay, the third one is triple covalent bond. It is formed when two atoms share three pairs of electrons. Okay, so three pairs means triple covalent bond. So we will see the example one by one. Okay, you look at the figure 5.7 here. It is a formation of single bond in chlorine molecule, okay, Cl2. So you look at the left diagram. Chlorine atom needs one electron to achieve a stable octet electron arrangement. Okay, so here the chlorine atom, the electron arrangement is 2.8.7. 7 is not stable, so it needs one electron to achieve a stable octet. Okay, so it needs one more electron to become 8. Okay, so what they do is they share electrons together. Okay, they share a pair of electrons. Okay, as you can see here, for chlorine, 2 electrons for the first shell, and then 8 electrons on the second shell, and 7 electrons on the third shell. 1, 2, 3, 4, 5, 6, 7. Okay, so the other chlorine atom also has the same electron arrangement. Okay, so what they do is they share one electron valence each. Okay, so look at the second at the right diagram. The two chlorine atoms each contributes one electron to share a pair of electrons to form a single bond in a chlorine molecule. So you can see now they share a pair of electrons to form a single bond in a chlorine molecule. Okay, now we count the electrons in the outermost shell, the valence shell. Yeah. So we count 1, 2, 3, 4, 5, 6, 7, 8. Okay, now the outermost shell becomes 8. So it means it has reached a stable octet electron arrangement. Both are stable now. So the electron arrangement becomes 2.8.8. Okay, why 8? Because the valence electrons is 8. Okay, just now 7 now becomes 8 because they have shared a pair of electrons. Alright, okay, the formation of covalent bond can be visualized using the Lewis structure. Okay, so Lewis structure only shows the valence electrons of the atoms involved. Okay, it only shows the outermost electrons only. Okay, a pair of electrons shared is represented with a line between the two atoms. Okay, so you see the figure 5.8, Lewis structure for the formation of chlorine molecule Cl2. So you can see this is the valence electrons. Okay, it only shows the valence electrons. Okay, so the atom chlorine has 7 valence electrons, right? Okay, and then plus with the chlorine atom, and then they share a pair of electrons, so it becomes like this. Okay, this is Lewis structure. Okay, or you can write like this. Okay, a line. Okay, a line between the two atoms means a pair of electrons shared. Okay, so this is the second example for the double bond. Okay, for the double covalent bond. Okay, so you look at the diagram first. Okay, on your left, Okay, oxygen atom needs 2 electrons to achieve a stable octet electron arrangement. So we look at the oxygen atom, the arrangement is, the electron arrangement is 2.6, okay, meaning the valence electrons is 6, okay, so it needs 2 more electrons to achieve 8, right? So it needs 2 more electrons. So what they do is, there are 2 atoms of oxygen here, so what they do is, you look at the right, 2 oxygen atoms each contributes 2 electrons to share 2 pairs of electrons to form a double bond in oxygen molecule. So now you look at the diagram, okay, the picture here. So the valence electron now becomes 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you look properly, the 2 electrons each share, okay, the 2 pairs of electrons. Okay, that means they share 2 pairs of electrons. So you can see around here. Okay, so now the valence electrons for both oxygen atom becomes 8. Okay, so 8 is stable octet electron arrangement. Okay, so look at down here. Down here is the Lewis structure. Okay, the Lewis structure only, sorry, the Lewis structure only shows the valence electrons. So 6 valence electrons plus with 6, and then they share here. See, you can see there 2 pairs. Okay, 1 pair, 2 pairs. So 2 pairs means double covalent bond. Okay, or you can write like this. Okay, one line means a pair, so 2 lines mean 2 pairs of electrons. Okay. Okay, so this is the example for the third bond, okay, for triple bond. Okay, figure 5.10, formation of triple bond in nitrogen molecule. So you look at the left, the nitrogen atom needs 3 electrons to achieve a stable octet electron arrangement. So we have 2 nitrogen atoms here. Okay, so the arrangement is 2.5. 5 means the electron valence. 1, 2, 3, 4, 5. Okay, there are 5 electrons valence. Okay, so it needs 3 more to become octet electron arrangement. So it needs 3 more electrons to become 8, right, for the valence. Okay, so what they do is, the 2 nitrogen atoms each contributes 3 electrons, okay, to share 3 pairs of electrons to form a triple bond in nitrogen molecule. Okay, it means like this. So this is the first atom. Okay, it shares 3 electrons. 1, 2, 3. Okay, it contributes 3 electrons. So the other atom of nitrogen also contributes 3 electrons. Okay, 1, 2, 3, 1, 2, 3. So the first one pair with the first one, the second one pair with the second one, the third one pair with the third one. So it becomes 3 pairs of electrons, okay, to form a triple bond. Now the valence electrons is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for a clearer picture, you look at the Lewis structure. Lewis structure is easier to see. Okay, N is 5. The 5 circles here is valence electrons, right? Okay, plus with the 5. Okay, and then when they share, you can see they share, they contribute 3 each, right? They 3 each. So the circle 3 here and the cross here also 3. Okay, they contribute 3 electrons to share 3 pairs of electrons. So this is considered one pair. Okay, 1, 2, 3. So 3 pairs mean a triple bond. Okay, or you can write like this. Okay, 1, 2, 3, 3 lines. Okay, because one line represent one pair, okay, of electrons shared. Okay, now I will show you 2 examples on single bond. Okay, another examples on single bond. So the first one is hydrogen. Okay, so hydrogen atom has 1 electron. Okay, the electron arrangement for hydrogen atom is 1. Okay, so this is the atom of hydrogen. Okay, we want to show you, I want to show you the molecule of hydrogen. Okay, next. Okay, Okay, each hydrogen atom contributes 1 electron for sharing with each other to achieve stable duplet electron arrangement. Okay, duplet also is stable arrangement. Duplet means 2 valence electrons. Okay, so now the hydrogen atoms has 1 electron valence plus with another hydrogen atom with 1 electron valence, and then it share. Okay, they contribute contributes 1 electron for sharing. Okay, so 2 hydrogen atoms share 1 pair of electrons to form 1 single covalent bond. So this is considered a pair of electrons, so it is single covalent bond. Okay, so the hydrogen molecule H2 is formed. Okay, so for the Lewis structure, okay, let me draw for you. The Lewis structure is like this. Okay, sorry. Okay, right. So a hydrogen atom, okay, with one electron valence plus with the another hydrogen atom, and then it form molecule, hydrogen molecule. Okay, now to see, they share a pair of electrons. Okay, or you can write like this. Okay, one line. Okay, represent a pair of electrons. Okay, so the second example is hydrogen chloride. Okay, still in single bond. Okay, look at the left side. Hydrogen atom has 1 electron. The electron arrangement for hydrogen atom is 1. Okay, so on your right, chlorine atom has 17 electrons. The electron arrangement for chlorine atom is 2.8.7. Okay, so 2 is here, 8 is here, and 7 is the outermost shell. Okay, okay, so now we look at the process. Okay, the hydrogen atom contributes 1 electron for sharing to achieve stable duplet electron arrangement. Okay, while the chlorine atom contributes 1 electron for sharing, also 1, to achieve stable octet electron arrangement. Okay, so you look at the hydrogen. Hydrogen has 1 electron valence, and then it contributes 1 electron for sharing. So when it contributes 1 electrons, and the chlorine also contributes 1 electron for sharing, you look at the product here. See, you can see a pair of electrons. They share together. Hydrogen has 1 and it share with the chlorine 1. Okay, both contributes 1 electron here. So now you look at hydrogen. Hydrogen has 2 electron valence. Now it called a stable duplet electron arrangement. 2 is duplet. Okay, while chlorine also has a pair of electrons sharing here, and then altogether the valence electrons is 8. 8 is octet electron arrangement. You count 1, 2, 3, 4, 5, 6, 7, 8. Okay, at the outermost shell. Okay, so 1 hydrogen atom and 1 chlorine atom share 1 pair of electrons to form 1 single covalent bond. Okay, so hydrogen chloride molecule is formed. Okay, so let me write for you the Lewis structure. Okay, so the Lewis structure for this one, maybe I write a bit, I write up here. Okay, I write up here the Lewis structure. Okay, so hydrogen with 1 electron valence plus with the chlorine has 7, right? 1, 2, 3, 4, 5, 6, 7. Okay, so I draw different shape to differentiate it. Okay, 1 circle, 1 cross. Okay, and then the product is like this. Okay, hydrogen contribute 1, chlorine also contribute 1. Okay, so both are stable. Okay, chlorine with the octet arrangement stable octet electron arrangement, while hydrogen is stable duplet electron arrangement. So this is the Lewis structure. Okay, they share a pair. See, a pair of electrons means single covalent bond. Okay, now I'm gonna share with you 2 more examples on double covalent bond. Okay, just now single covalent bond, now double covalent bond. Okay, so oxygen atom has 8 electrons. Okay, the electron arrangement for oxygen atom is 2.6. So it has 6 electrons valence. Okay, it has 6 valence electrons. Okay, look at the process, how they share. Okay, alright. Each oxygen atom contributes 2 electrons for sharing with each other to achieve stable octet electron arrangement. So we have 2 oxygen atom here with 6 valence electrons. Okay, 1, 2, 3, 4, 5, 6. This one also 1, 2, 3, 4, 5, 6. So what they do is they contribute 2 electrons for sharing. Both contribute 2 electrons. Okay, when they contribute 2 electrons, now we count the valence electrons for each atom. Okay, so for the first one, 1, 2, 3, 4, 5, 6, 7, 8. Now it has reached the stable octet arrangement. Okay, the other oxygen also the same because they both contribute 2 electrons for sharing. So we count the valence for the, we count the valence electron for the second atom. 1, 2, 3, 4, 5, 6, 7, 8. So same. Okay, it has achieved a stable octet arrangement. So two oxygen atoms share two pairs of electrons to form one double covalent bond. Okay, two pairs means the first one is this one, 1 and 2 is one pair, and then the second one 1 and 2, so two pairs. Okay, understand, yeah? Okay, let me draw for you. Okay, this is one pair and this is another pair, so 1 and 2, so two pair means means a double covalent bond. Okay, so oxygen molecule is formed. All right, so let me draw the Lewis structure for you. Okay, let me draw here. Okay, so the first one, oxygen with the six electrons. Okay, plus with oxygen. Okay, same 6 electrons. Okay, electron valence. Okay, and then it produce more oxygen molecule. Okay, they share two pairs, right? Okay, so they contribute 2 electrons. Both contribute 2 electrons. Okay, all right, so this is the structure Lewis. Okay, or you can do like this, the line. Okay, like this. Why two lines? Because one line represent one pair, so two line means two pairs. Okay, so it is a double covalent bond. Alright, so the second example for the double covalent bond. Okay, a carbon atom has 6 electron. Okay, the second example is a carbon dioxide. Okay, CO2. So on your left, carbon atom has 6 electron. The electron arrangement for carbon atom is 2.4. Okay, so you can see the 4 valence electrons. And the oxygen atom has 8 electrons. The electron arrangement for oxygen is 2.6. So that means it has 6 electron valence, 6 valence electrons. Okay. Okay, so look at the next process. Okay, so the carbon atom contributes 4 electrons for sharing to achieve stable octet electron arrangement. Okay, remember, carbon atom contributes 4 electrons. Okay, while the oxygen, we have 2 atom oxygen here, so each oxygen atom contributes 2 electrons for sharing to achieve stable octet electron arrangement. Okay, you must look properly. Okay, you focus on the carbon atom first. Okay, focus on carbon atom. Okay, this is the carbon. Okay, so this is the outermost shell. Okay, it said that the carbon atom contributes 4 electrons. So the 4 electron is here. 1, 2, 3, 4. See, it contributes all the 4 electrons. Okay, for sharing. Okay, and then the oxygen atom contributes 2 electrons for sharing. Okay, I change color to yellow. Okay, while for the oxygen, you can see this is the valence shell. Okay, it contributes 2 electrons, right? So the 2 is here, 1 and 2. Each oxygen atoms contributes 2 electrons, right? Okay, now if you count the carbon, if you count the electrons valence for the carbon, now it has 1, 2, 3, 4, 5, 6, 7, 8. So carbon has achieved octet electron arrangement. Okay, and the oxygen, we count the oxygen for the valence electron for oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Okay, still 8. So 8 is octet electron arrangement. Okay, so they both are stable. So one carbon atom and 2 oxygen atoms share 4 pairs of electrons to form 2 double covalent bonds. So the carbon dioxide molecule is formed. Okay, 2 double covalent bonds. Okay, you must understand it. Okay, why 2 double covalent bond? Okay, it means like this. This is a pair. 1 pair, 2 pairs. Okay, 1 pair, 2 pairs. Okay, so this is another, the third pairs and the fourth pairs. Okay, so that's why it said 4 pairs of electrons. Okay, that's why it said 4 pairs of electrons. And we know that, okay, what color I want to use now? What color? Okay, we know that, okay, two pairs considered one double bond. One double bond. Okay, so this is another two, right? Another two. So this is another one double bond. Okay, so one double bond plus one double bond, that's why you get two double covalent bond. Okay, you must be very careful on this. Okay, okay, now let me draw for you the Lewis structure. So the Lewis structure is I draw here. Okay, not enough space. I think I want to draw here. Okay, this is the Lewis, okay, structure. Okay, so the oxygen 6, okay, 1 2 3 4 5 6, okay, plus with the carbon with a 4 valence electrons, okay, 4, and then same thing for the oxygen, 1 2 3 4 5 6, and then it produce a carbon dioxide molecule like this, OCO, right? Okay, OCO. So 1 2 3 4 5 6 7 8. Okay, 1 2 3 4 5 6 7 8. So both have 8 valence electrons now. Okay, or you can draw like this. Okay, this is a one double bond. So this is another one double bond. Okay, so that's why it said two double bond. Okay, covalent bond. Two double covalent bond. Okay, I hope you understand. Okay, now this is the example for a triple covalent bond. Okay, for triple covalent bond, nitrogen atom, for nitrogen, okay, nitrogen atom has 7 electrons. The electron arrangement for nitrogen atom is 2.5. Okay, so 2.5 means the 5 valence electrons here, 1 2 3 4 and 5. Okay, and then look at the next process. Okay, each nitrogen atom contributes 3 electrons for sharing with each other to achieve stable octet electron arrangement. So you can see here there are 2 nitrogen atoms, so it contributes 3 electrons, okay, for sharing. Okay, it has 5 actually, 1 2 3 4 5, and then both contributes 3 electrons for sharing. So you can see the product here, we count, it shares 3, right? I mean contributes 3 electrons for sharing with each other. So 1 pair, 2 pair, 3 pairs. Okay, so we count the valence electrons, 1 2 3 4 5 6 7 8. Okay, now both have 8. Okay, so they already achieved stable octet electron arrangements. So 2 nitrogen atoms share 3 pairs of electrons to form a triple covalent bond. Okay, so in here it is an example. It is an example for triple covalent bond. Okay, so this is the first pair, second pair, third pair. Third pair means triple covalent bond. So nitrogen molecule is formed. Okay, so let me write the Lewis structure for you. Okay, so the Lewis structure is like this. Okay, sorry, it's very hard to control my pen. Okay, so a nitrogen has 5, right? So 1 2 3 4 5. Okay, plus with another nitrogen, 1 2 3 4 5, and then they share together the 3 electrons. Okay, 1 2 3, they share, right? 3, so it becomes stable. Okay, all right, or you can write like this. Okay, 1 2 3, 3 line. Okay, 3 line because it has 3 pairs of electrons. Okay, so I hope you understand. Okay, so look at figure 5.11. So it is a comparison between ionic bond and covalent bond. Okay, so ionic bond you have learned in the previous lesson in subtopic 5.2, and the covalent bond is now 5.3. Okay, so the similarity is involve valence electrons. Okay, the first one. Second one is the atoms achieve stable octet or duplet electron arrangement. Okay, so the stable arrangement is either octet or duplet. Okay, look at the ionic bond. Okay, what's the characteristic in ionic bond? Okay, it transfer of electrons. Okay, it means the electrons are transferred. Okay, either it donates or receive. okay, donates or accept, okay, they don't share, they transfer the electrons, okay. And then it is between metal atoms and non-metal atoms, okay, and then it forms a positively charged ion and a negatively charged ion, okay. While covalent bond, they share electrons, okay, sharing of electrons, okay, they don't receive or they don't donate, but they share electrons, okay. And then it is between non-metal atoms, okay. The third one is it forms a molecules. All right, so I hope you understand this subtopic, okay. Okay, so please do test yourself 5.3, okay, in your textbook, okay. So please do these 5 questions, okay. State 3 types of covalent bonds you have learned, okay. Single bond, double bond, right? Okay. How are covalent bonds are formed? Okay, it's stated in this in my PowerPoint slide. Okay, it also can you can find in a textbook, alright. And then third one, draw the formation of covalent bonds in the water molecule. So it's easy, okay. Please look at the electron arrangement, okay, and try to do. Okay, number 4, can carbon atoms share electrons with 4 hydrogen atoms to form a methane molecule? Okay, so you look properly at the arrangement, okay. And then state 1 similarity and 2 differences between ionic bond and covalent bond. Okay, so I just explained to you the differences and the similarity. Okay, so I hope you can do the exercise. Okay, once you have finished, please snap your answer and send to me. Okay, thank you.